Good afternoon, everybody. I'm here. We're going to do chapter 10 today, so hope all is going as well as possible. Basically today, it's a little bit more complicated of a formula, but it won't be so bad once we take a look at it. The nice thing about this one is it's more about being careful with your steps and your numbers than it actually is the complicated aspects of the formula. So we're allowed to go through and kind of run through a shortcut version of it, so it'll be a little bit easier once you actually get to the homework. So I want to go through the steps first and give us a little bit of background before I actually go through the specifics. So again, this week we're continuing the exploration of hypothesis testing. In this case, how we test if we got it right, but it'll be with nominal variables. So there's two things to review here. One being hypothesis testing in the sense of essentially we're taking a look at how well our sample aligns with the normal curve. And this is over here. So if you take this orange line to be our sample and then along the normal curve, we're trying to see how closely these two align. The more closely it aligns, the more likely it is that we got it right, because it approximates normality. Okay, so that's what hypothesis testing has been so far. But we're at sort of a unique problem with nominal data. Because if you recall, nominal data is data that isn't very mathematical, for lack of a better term, because it doesn't necessarily line up with strict numbers. And so basically these are the ones that are in name only. So things like people's names, sex or gender, political party, etc. So we're not able to meaningfully turn it into a number. So for instance, male, female, these aren't necessarily numbers. We just sometimes might put a 0 and a 1. It's just random numbers. It could be anything. So part of the problem with that is because it's a nominal data, it's not necessarily going to look like this. So we need to do something slightly different because nominal data doesn't necessarily follow along a normal distribution. So, of course, we have a test for this. It's called a chi-square test. And it looks like chi-test, but it's called the chi here. It's pronounced chi. So the chi test is a way for us to test nominal variables. Because we cannot use the math of other tests, we have to type out the equation. We have to use an equation that gives us our best bet. So essentially, the testing is comparing what we got, that's number one, with what we should have got, which helps us estimate how closely or what we got aligns with what we should have got. So it's less of a test how right we were and more a test of how strong the relationship is between the two variables. So what we got versus what we should have got, and it's testing the strength of the relationship. And I'll circle that because that's going to be important. In general, any sort of testing we do for nominal variables is testing the strength of the relationship. So when one variable shows up, how likely is it that the other variable will show up? And we can't do much more than that with a nominal variable. And another thing to remember right here is with this formula, basically the bigger the number you get, so the higher the number is, the higher this chi-square number is, the stronger the relationship is going to be. So the higher the number, the stronger the relationship. Okay. So I'll go through the steps briefly here, taking a look ahead, and then I'll go through the actual formula step by step with our numbers. And it'll help us take a look. And it's be very similar to what the homework's going to be. The homework will just be a little bit longer as far as a little bit more numbers involved. But the same steps are going to be in play. Okay, so taking a look ahead. So essentially we're going to look at two different equations. The chi-square equation and one called the pre equation, PRE. The pre one is much easier than the first. So I'm going to go through the more difficult one first, the chi-square formula, and then the pre formula second. They're both only take a few steps, and kind of once you get the hang of it, it really becomes less about the complication of the equation and more about just how careful you are with keeping track of your numbers. Okay? So here is a review of the steps. So there's essentially going to be 6 steps in the chi-square test. One, and again, this will be a review, but I'll go through these steps in more detail in just a bit. So one, our assumptions are going to be it's a random sample, because like with any hypothesis testing, we want to assume that it's random. And of course, they're nominal variables, so we have to change it a little bit in order to actually test it, because we can't use the normal curve. Okay. We're going to be testing hypothesis and null hypothesis, just like in regular hypothesis testing. We're going to use a chi-square test. The next step would be calculating degrees of freedom, just like we have before, so we can look it up on the chart. There's a second step here, which I'll go into more detail. It's specifically for 2x2s. And a 2x2 table just means it's 2 columns by 2 rows. And I'll show you what that looks like. Our example is one of these. 2 columns by 2 rows. And then finally, just like any of our other ones, we're going to look it up on a chi-square table, which looks a lot like the z-score table. Okay? Scrolling down. Okay, so here's a problem, and they're using SPSS data, or GSS data. So the research was looking at first-generation students. It determined if there's a difference between genders. Interested in seeing if there is a difference between self-identified men and women in coming to college among first-generation students. Okay, so let me zoom out a little bit. So here's a chart here. So here's a chart. So this is a 2x2, because there's 1, 2, 2 variables here, and 1, 2 variables here. Meaning it's going to be 2 rows and 2 columns. So this is a 2x2 table, just by definition. Okay. So what we can see here is it's separated by men and women, first generation and non-first generation. And so 41% of 41.9% of the students are men, or 41.9% of students are first generation, and 58.1% of students are non-first generation. So what this chart is showing is this is us assuming that because we know that 41% of students are men and 58% are because we know that 41.9% of students are first generation, and we know that 58.1% of students are non-first generation, we're going to assume that it's going to be the same for men and women. We're going to assume that 41% are men and 41% are also women, because there's no reason for us to think that there's going to be any difference among gender between first generation and non-first generation, between men and women. Okay? So we're going to assume that there's no relationship. Therefore, if we know that of the first generation students, 41% of them are men or women, and of the non-first generation students, we assume that the 58.1% are non-first generation students. We're going to assume that it's the same number for both. So if we look at that. And 2, so basically that's what's going on over here. We assume no relationship between the genders, because we don't think there's going to be any difference. Okay? But here's what they actually did. So when they actually went through and collected the data, these researchers, when they asked all the students, let's say for instance at College of the Desert, when they asked all the students, all the first generation students and all those non-first generation students, and then they asked them what their gender was, they actually found something kind of surprising. So if you look here, rather than the 41%, rather than the 41.9% up here that we assumed, there's actually a difference. We see that only 35% of men were first generation, while 46% of women were first generation. And we also see that a non-first, 64% were men and 53% were women. So we see that here's our assumed numbers from up above. We see there's actually a difference between the two. So now the researchers actually think, okay, so it does look like there's a difference, but how strong is this relationship? So they're going to test their hypothesis that there's a gender difference between men and women in first and non-first generation students. So how do we do that? So this is where the chi-square test comes in. So also this is the basic formula here. We'll go through it in just a little bit. But essentially here, they're seeing how strong the relationship is. They want to see how strong first generation status is with gender or sex. So essentially what they're going to do is see what they actually got when they took the survey, and compare it with what they expected to get, where there was no difference. So we're comparing what we got with what we thought we would get. So in the formula, the O, that means observed, which means the ones of what you actually got, what we got. And the E is what we expected to get, or what we thought we were going to get. Okay? Those are the only two things you really need to know here. And this one right here should be familiar because that's the sum. That's when you add everything together. So let's go through the steps. So here's the chi-square formula, step 1. Use the expected formula. So with any of these questions, before you could actually go in and fill in this chart, you're going to need to calculate the expected. So here's what we're going to do. So you're going to take the observed, the ones you actually got. So if you look, this is the one when they took their survey, these are the numbers they actually got up above. And what they're going to do with that is they're going to run it through the formula. It's simply this one up here. And they're going to end up producing a new chart. Okay? So here's what that looks like. So essentially what you're going to do, what you're seeing up here, if you recall, it's column marginal times row marginal. And you're going to do all of that divided by the total number. Okay? Column marginal times row marginal divided by the total number. So you're always going to be looking at the extremes. So here, let's do this one first. I'll chart this one off. This is first generation men. First generation men. And that one is going to go over here with first generation men. So this is the number you get. What you're essentially going to do is you're taking the column marginal. So if you go out to the edges, the marginal, you're going to take that number. So this is first generation men. You're going over here. You're taking this number and you're going to multiply it by this number, number 1, number 2, and you're going to divide it by the total number, 4620. So let's go ahead and do that. So we're going to go ahead and take this one, the 1936. I have my Google calculator open here. 1936. And we're going to multiply it by the 1950 down here, number 2, times 1950 equals. And then you can divide it by number 3 here, the 4620. Divided by 4620 equals 817.14 right here. And that's where your number is. See, over here, number is 817.14. Okay? So let's do that for the second one. I'll do a quick erase. Okay. Some of these are not going to erase. Okay. So let's just switch out the color here. Okay, so let's go ahead and do this one over here. Women, first generation women. So we want to look in first generation, and we want to look in a women's category. So we're looking here. We're looking there. And so we want to take the marginal. So it's going to be this one again. That's going to be the number 1. And now we're going to go down here. The marginal here is this one. That's going to be number 2. And this is always going to divide it by this one is be number 3. So we'll go ahead and go back to our calculator. 1936, which I got right here with the number 1, times 2670. 2670 equals, and we're going to divide it by 4620 down here. $1,118.85, 1118.85. You'll see that that is this number over here. So we've created that one. Okay. Okay, let's go ahead and do the next one. Green. Okay, so let's go ahead and do non-first men. So non-first men is here, and we're going to take the marginal, 2684, and the 1950, number 1, number 2, and number 3. Okay, so take the first number, 2684, in our calculator, 2684 divide, 2684 times number 2, 1950, 1950 equals, and divide it by the number 3, the 4620. Okay. And we get this number right here, the 1132.85. We're going to round it up to 0.86. Okay, get that number. And finally, you do the last one. And really, for any problem you're doing, you're going to do this no matter how many rows or columns there are. So for this one, it's a 2x2. So we're going to go through and do it like that. Okay. Let's go ahead and do yellow. Okay. So let's do non-first generation women. So this is the number we're going to be looking at. So go over here, the marginal, number 1, number 2, and finally this is number 3. Okay, so number 1, you take 2684, times 2670. Finally, number 3 divided by 4620, 1151.14. You got this one, 1151.14. Okay. So now we've done the first step. First step is created the expected. The expected frequencies. Okay, so we're going to be using these numbers in this chart kind of throughout with a lot of the math we're going to be doing. So you want to keep track of these. If you're doing this as a homework, make sure you keep track of these numbers and make sure you know which category they're associated with. I would suggest actually drawing out a chart so you can keep track of your numbers. Okay, so now we have the expected. Okay. So now we could actually go in and start using the chi-square formula. Because we have the observed and we have the expected. So now we could actually go in and plug these in. So I'm going to read through the steps, and then I'll show you what it looks like. So in verbally, you want to do the parentheses first. So we're talking about these ones right here. The observed minus the expected. You're going to square that number. Square that number. You're going to divide by the expected. Expected is the chart we just made. And then after doing all this, after doing these 3 steps, you're going to add them all together. And that's what the sum is all about. Okay? So do the parentheses first, observed minus expected for each one of the categories. You square the number, divide by the expected. Then after you do these steps for all of them, you add them all up. So what does that look like? Okay. Zoom out just a little bit. Okay. So let me zoom out a bit here so you could see what I'm doing. Okay. So here's the 1, 2, 3, 4 different formulas. And essentially what each of these are is this formula up here. Okay. So let's take a look. I'll read through it and then I'll show you where they all came from. So this is going to be observed, this first one here is observed minus expected squared. And what I'm taking is observed minus expected. And I got this number. And then I'm dividing by the expected again. And then you get your number. Okay. So this number, 1947, is for first generation men. So first generation men. Okay. I'll show you which ones I did for the next one. Let's change colors again. Okay, let's do first generation women. So first observed 1245 minus 1118.86. You get your answer. And you divide by the expected. And again, it's the same as the formula up here. That's this formula up here. And then you got your number here. That's your number for first generation women. Let's take a look at non-first generation men. Non-first generation men. So you see 1259, non-first generation men, minus the expected. So 1259 minus 1132.86. And again, divided by the expected. And you get this one. It's 14.05. That's the number for non-first generation men. Let's do one last one for non-first generation women. So 1425 minus 1151.14 squared divided by the expected. Get 10.26. So essentially, no matter how many squares you have, you want to do this step for every single one of them. You want to do observed minus expected squared all over expected for each and every category. And that's what we have here. So we have for 1, 2, 3, 4 categories. So if we're going to go down then, the final step then is after you do this for every single step, we've got one for every single one, we're going to add it up. Okay? So in this case, we got the number 58. So when you take 19.47 plus 14.22 plus 14.05 plus 10.26, you get the number 58. So that would be your number. That would be the full formula in most cases. So when I say this, because remember this is a 2 by 2, 2 rows, 2 columns. This one doesn't have one extra step in it. But say for instance this was a 3 by 2 or a 2 by 4, 2 rows, 4 columns, 3 rows, 2 columns, and then you wouldn't have to do this next step. The reason I point this out is because on your homework I think is at least one of them is going to be is not going to be a 2 by 2, so you wouldn't have to do this next step. Okay, but just for this example, it's a special case. You have to do one more step before you can look it up on a chi-square chart. Okay, so we just briefly say it again. So up here, this is the chi-square formula, and this will normally get you your final number, and you could go immediately look it up on the chart. So normally, after you calculate all these numbers, and you get to this last step and add everything up, this number right here, you'd go directly to the chi-square chart and look it up. The chi-square chart is very similar to the z table we've been looking at before, but because this one happens to be a 2 by 2, you have one extra step. So on your homework, if you have one that is not a 2 by 2, you can go ahead and skip this step and go immediately to the final step of looking it up on the chi-square chart. Okay. So this one's actually really easy. It looks complicated right here, but essentially you've already calculated most of these numbers. And this is called the Yates correction, and it's only for 2 by 2s. So it's essentially like very similar to what your original number was, and most of the time it's going to be very, very close to the same answer. Okay? So let me, we'll go through the steps. So, and most of them you already have, like I said, so you can go ahead and look above and take your answers from before. Okay. So the first 2 steps, you're actually just going to have to calculate one number, and it applies to all of them. Okay. So, first step, you're going to get the non-zero value of observed minus expected. So if you're interested in where this is in the formula, this is right here in the formula. We're going to do that one first because it's in the parentheses. So the reason I say it's the same number, so right here. So from above, I'll go through 2 of them to show you what I mean. So from above, you take any observed minus expected. So let's go back up and look at any of our numbers. So for instance, we could take, let's take this one right here, for instance. Any observed minus expected. So the observed in this case was 691. 691 minus 817, and this is for first generation men, minus 817 equals negative 126. Okay? Let's go ahead and do this one over here. So this is for first generation women, 1245 minus 1118.86 equals negative 1 or equals 126. We'll take the next one. 1259 minus 1132.86. 1259 minus 1132.86. Negative 1 or is 126.14. So the reason I say this is for this first step, you could do any of them, any observed minus expected, and you're going to get the non-negative values. So for instance, that first one, 691 minus 817.14 equals negative 126.14. So you just want to take you just want to make that a positive number. So you just calculate this once. That's the first one you need. step 2, and step 2 is this part right here. If you look at the formula, you're going to subtract 0.5, 0.5 from the number you just got, and then square your answer. So I'll show you what I mean. So for instance, you take your 126.14. Let me just edit that real quick. You go ahead and take the answer you got from last time, the 126.14, and you're going to subtract 0.5. Okay. So let's go ahead and do that on our calculators. 126.14 minus 0.5 equals 125.64. This should be 125.64. Then you're going to square your answer. 125.64. Then you're going to square your answer. 125.64 times 125.64 times 125.64 equals 15,785.41, or 4096. 15,785.4096. So as we saw, we had a 125.64 squared, and we got the number 15,785.4096. So we have that number. Step 2 is complete. This is the number you want to keep track of. So this is the one where you're going to, is a little bit more. All you have to do is take the number you just got. So step 3, you go through and you're going to divide each of your expected from each category. So you can see this number over here is going to be the same each time as the number we had up here. And you can just divide it by the expected from each category. So you take your 15,785.4096 divided by the expected category. And these are all the expected categories from up here. 817, 1132.86. So you can see we did it for each category. This is first generation men, first generation women, non-first generation men, non-first generation women. You get each of these answers. And just like before, your final step after you calculate all these for each category and add them all up. So this time you get 57.54 as your final answer, your chi-square number, whereas right before you did it, you got 58. So very close in number because you only subtracted that 0.5 from each category. But it's important to do these in 2x2s. Scroll down here, so you add them all up, 57.54. And this is then the final step where you're going to look this up on the chi-square table. So here's a picture of the chi-square table. I'll link one in our notes. Okay, so step 1, calculate the degrees of freedom, which is over here. And this is a really simple one. If you look at it right here, it's R minus 1 times C minus 1. And R here simply means rows, and C means columns. So since we had two rows and 2 columns, it's 2 minus 1, which equals 1, times 2 minus 1, which is also 1, which equals 1. So your degrees of freedom are going to be right here in 1. And now step 2, you take the chi-square number you just got, 57.54, and you're going to look it up on the chart. So basically what you do is you're in this row now and you go across the chart until you find the number you got. In this case, the biggest number we have is 6.63. That's the biggest number we get, and it's up here at the alpha of 0.01. So if you recall then, all these numbers on top, these numbers at top are all indicating the chances of you getting it wrong. So over here, the further left you are, the more wrong it is. And the further right you are, the more likely it is that you got it right. Okay. So as you see, the number on top gets smaller and smaller. So by the time you get to the very end, if you have anything above the 6.63, you're going to know it's very likely that you got it right. Okay, so the highest number you see, 6.63 at 0.01, which is the 0.01% chance you got it wrong. We got a 57.54. So we can conclude then we have less than a 0.01% chance of getting it wrong. And just a hint here at the bottom, the bigger your number, the better, like I said in the very beginning. So the minimum number you need in this case, you want to ask yourself, you say at 6.63, is the number I got greater than 6.63? And our number in this case was the 57.54, which is indeed greater than. So we can conclude then, we could reject the null hypothesis and assert that gender does play a role in first generation students. So we could say then, because remember this is testing relationships, we could say then that there's a strong relationship between someone's gender and whether or not they're a first generation student. Okay, so we could safely reject the null hypothesis and assert that gender role does play a role in first generation students. Okay, so that's the first one. And as far as this goes, when you're doing your homework, they're going to be bigger than 2x2 charts. They'll be bigger than 2 rows and 2 columns. So the thing I would emphasize is being very, very careful in writing these out so you can keep track of all of your numbers. Because the easiest way to mess up on this is to lose track of where you're at. Okay. Scroll down a little bit more. So this is the second equation we're going to be taking a look at. This one is actually much quicker. There's only 3 steps to this problem, much easier than before. The advantage to this one, so this is called a proportional reduction of error. The advantage to this one is it actually gives you a result of how strong or weak your relationship is. Or when we were talking about the chi-square number, it shows you how likely it is you got it right or wrong. But this was going to tell you how strong the relationship is. So this one, instead of having a very large like chi-square chart or z-table to look at, it's only going to be a very small chart, a small spectrum. And the number is only going to be between the -1 and 1. And the closer to -1 means a strong negative relationship. 0 means no relationship. And 1 means strong positive relationship. And we'll go more into that at the very end when I show the chart. It's just to keep it in mind. And this over here is the overall equation. It's very small. All you really have is 2 different things. You have error 1 and error 2. You just have to plug them in. So there's 3 steps to this problem. Right here, calculate error 1, or E1. Step 2, calculate error 2, or E2. And finally, you just plug those numbers in, and you interpret it on the chart. So here's how simple it is. Okay. So the problem. In this case, the researcher is looking at the relationship between a person's education and their support for abortion. To do this, they look at whether someone has a bachelor's degree or higher, or doesn't have a degree, and they compare this with supporting or not supporting abortion. So you can see this here. This is a 2x2 chart. Support for abortion, no or yes. And here's their degree, whether they have a less than a bachelor's or more than a bachelor's. Okay. So they're going to use these numbers to calculate the whole equation. Step 1. Simply in step 1, you're calculating the error for error 1. So hint, in all of these, it's always going to be taking the marginal. So things on the edges, the marginals are always the one on the outside, or the one I have circled here. Okay. Minus the mode in each category. So in this case for E1, we're only looking at this last column. This last column here. And we're going to take the marginal from the total. So in this case, the marginal, and the marginals are always going to be on the outside. In this case, the marginal is here. And for all of these, the marginals are always going to be down at the bottom like this. But for E1, you're specifically looking at the marginal for here. So that's 940. And you take away the mode, or the most common number. And from here, you could see mode is always the biggest number, most common, or the biggest. In this case is the 586. 940 minus 586 is 354. Error 1 is 354. That's all. So save that number, put it to the side. You're going to need it. I'll show you error 2. Error 2 is the same idea, only it's looking at it in a slightly different spot. Okay, so it's going to be looking in the rest of the columns. So while error 1 was looking here, error 2 is going to be looking in these two right here. Okay. So you're going to do the same thing as before. You're going to take the marginals and you're going to subtract the mode and then add them up at the end. Okay. So step 1. I'm taking the 270, which is here in this column, minus the mode, in this case is 146 because it's the biggest number, and you get 124. That's one number. You do the same thing for the second column. You got 670 because that's the marginal, minus 462 is the biggest number in that category, and you get 208. So here's 1 and 2, and now the final step, you add them together. 124 plus 208 equals 332. Your error 2 then is 332. Save that number, put it to the side, and now you simply are just going to plug it into the equation. So we saw their equation is up here. The PRE is error 1 minus error 2 divided by error 1. That's a formula. So all I did is I looked above and I took my numbers. Error 1 of 354, error 2 of 332, and my first step is I subtracted 354 minus 332 and got 22. I did that first because it's in the parentheses, and then divide by error 1, which is 354, and I got 0.06. Let's take a look at that on the calculator. So 354 minus 322 equals 22. That's where 22 came from. And you divide by 354, because that's error 1. Divided by 354 equals 0.062. So for these ones, you're going to round to the second decimal as before. So 0.06 is your PRE number right here. And now you just plug it into the spectrum down here. So here's the chart. Chart's down here. And you can see that this chart, it goes from a positive 1 all the way to the negative 1. So you're basically going to try to find our number, 0.06. And you can see that 0.06 is probably somewhere around here. So on our scale then, you can see it's a weak positive relationship. It's almost a non-relationship because it's so close to 0. So we can determine it's a very weak relationship of 0.06. And it's very close to 0, meaning it's very close to having no relationship at all. So there's a very weak relationship between someone's education status and someone's views on abortions. So this would mean, if you were to interpret this a little bit further, this would mean that knowing someone's education level only improves our ability to predict the stance on abortion by 6%. Very, very small relationship, so very weak in predicting things. And that's basically how you do any problem that looks like this. When you calculate the pre, you would just look at this chart here and try to determine how close these relationships are. And as a reminder, any of the SPSS problems that we have, while we don't have our access to the computers at the campus, you don't need to worry about doing those. They're going to be worth 0 points for now, so leave them blank for the homework. And also, these charts are all in your book if you have the book, or they're in the notes you could download from our Canvas page. Canvas, I have all these notes fully typed and printed out, so you could go on there and download them and look at them on Word or use them however you wish. So good luck with all this, and I will talk to you all next week.